Okay, guys, let's go through your warm-up here. Draw. Clearly not a polar grid, but that's okay. We'll still graph on here. So r equals -2 cosine theta. If I just said to graph the entire thing, where would that be? Or what is it, I guess? Start there. Okay, a circle, and where is it?
2.
Which way?
The diameter of 2.
Okay, and is it up, down, left, or right?
Left, yeah.
Okay, so if I was drawing the whole thing, it would be over here somewhere, right? I'm not, though. I have this window. Now, you guys had one kind of like this on your homework. Is my circle anywhere between 0 and pi over 2? No. So some of you were thinking, oh, there's no answer to this because my graph didn't show up between 0 and pi over 2. That's not what that window is telling you. Okay, that interval's not saying this is where the graph will be. It's saying here's the theta values you can use to graph this. So let me get rid of this one. If I were to make a little r theta chart, I could plug in thetas between 0 and pi over 2. Okay, so let's start with 0. What's the cosine of 0? 1 times -2, so we're here. So we've got that guy. What would be easy to pick for cosine between 0 and pi over 2? Pi over 3, good. What is the cosine of pi over 3? 1/2. So what's the r value then? -1. So that means go left 1 and then pi over 3 from there. So it's kind of, obviously I'm eyeballing it with just an XY grid. And then what if I plug in pi over 2? What's the cosine of pi over 2? 0. So we're back here. So it is this side of the circle that you get going from 0 to pi over 2. Does that clear up that issue, guys? With, I think the homework, it was like from 0 to, or pi to 2 pi, but your graph was up top, something like that. Yeah, it's not saying where the graph will show up. It's just the values you can plug in. Okay? All right, let's try number 2. Okay, again, if I'm just graphing this whole thing, where is it? Or what is it? Down. What's the diameter?
It's 3.
3, and it's a circle, right? Everybody okay with that? So again, it would be this whole thing. But we've got a window, so I got to figure out, am I graphing the whole thing? Am I not? What's happening here? So make a quick little table. I know I'm going to start with pi over 2. I know I'm going to end with 3 pi over 2. You might want to do 1 or 2 points in the middle. It's up to you and how comfortable you feel graphing it. I'll probably do 2 this time. So guys, what is the sign of pi over 2? 1. So what's the r value here? Okay. So -3. And then count around to pi over 2. That's where that point ends up. What do you want to use for sign in between pi over 2 and 3 pi over 2? What would be easy? 5 pi over 6? Okay. Yeah, over 6's would be good. So what is the sign of 5 pi over 6? 1/2. Okay, and then what would the r value be? Okay, -3/2. So I'm going to go over -1.5, and then I have to go all the way around 5 pi over 6. Eyeballing it, that's somewhere over here. Before I get to 3 pi over 2, what else might I want to pick? What's another good sign value to pick? We could do pi, sure. What do I get with pi? 0, yeah. I've got that. If you wanted to, you could also do 7 pi over 6. But we can keep going with 3 pi over 2. If I plug in 3 pi over 2, what do I get? Yeah, I get 3. So that means start at 3, end down here. So if I skip, let's do it just because it's hard to see what's happening on the other side. What if I plug in 7 pi over 6? What is the sign of 7 pi over 6? 1/2 or negative 1/2? Negative. So what's the R value then? 3 over 2. Okay. So starting over here at 1/2 and going all the way around 7 pi over 6. Do you guys see how it's still going to be the whole circle? This distance was like half of your 0 to 2 pi. And it covers all your positives and negatives with signs, so you get your whole circle graphed. Okay? How many got number 2 right? Okay, questions, guys. You're sort of looking at me with this like glazed over look in your eyes. So what are we stuck on to? Are we confused on something? Please ask if you're stuck. Don't just sit and stare. Yeah.
Plug numbers in every time then?
So if it doesn't have a window, if it just said graph this, like, or if it says from 0 to 2 pi, anything like that, you just know, oh, that's a circle down there. Just draw it like that. If it has an interval, though, you'll get better at recognizing them. Like, I know, like, looking at this one, I was like, oh, yeah, that's going to be a whole circle, whereas the top one, that window, I'm like, yeah, that's only going to be half the circle. Because I know if I go from 0 to 2 pi, I'm actually drawing the circle twice. So you get better at picking that stuff out. But if you're unsure at all as far as how much of the graph is going to show up, definitely plug in a few points. Okay? Are we okay? All right, the last one hopefully was the easiest one. So this is r equals 3 secant of theta. Are we okay with that's really 3 over cosine of theta? Okay, so that's r cosine theta equals 3. What does that mean? X equals 3, so vertical line at 3. Did we do okay on that one? Yes, okay. All right, guys, questions? Questions on the homework? Any part of that? There were only 6 graphs, I know. Are you okay on number 2 now? I know that's one that a lot of you guys had questions on, but after that warm-up, are we better? Or do you need to see number 2? You want to see it? Okay. All right, if there's no window there, what kind of graph is this? Circle, up, right? Up on the y-axis, diameter of 4. A lot of you were like, well, but hey, pi over 2 pi is down here. It's not going to show up. That's, again, not what that means. That means if you were to plug in values, you could plug things in between pi and 2 pi. So what is the sign of pi? 0. So there's your first point. What might you want to plug in with sign between pi and 2 pi? Yeah, 7 pi over 6. What's the sign of 7 pi over 6? Negative 1/2. So what will r equal? Okay. So that means you start out over here left 2, and then you travel all the way around 7 pi over 6, which puts you in that quadrant. That's how you plot those points. That's why we plotted points in 8-1, guys, so we could make sure we know how to do this. Maybe I want to pick 3 pi over 2. What's the sign of 3 pi over 2? Negative 1, so what's r? So again, I start over here, but I have to travel all the way around to 3 pi over 2. So 1, 2, 3, 4. Okay. Let's do one more. Let's do 11 pi over 6. So what's the sine of 11 pi over 6? Yeah, Dave.
You have to do every point within the window.
No, you have to do enough so that you know what's happening. Which, if you look at it and you kind of start even just mentally thinking through it and you're like, oh, well, this is an interval of pi, like that whole distance is pi. I know I'm going to get the whole circle. I'm just going to draw the circle. Do that. That's great. I want you to see those things. I'm not going to be like, there was no chart. You didn't get your point. No, like, hey, yes, you can graph that. Where I think it's harder is, let's say it was 3 pi over 2 to 2 pi. Hopefully you get to the point where you go, okay, that's going to be half the circle. I think it's harder for you to see the half of the circle that it is. But once you get to the point where you can see that, great, just graph it. Yeah.
So if it's like a thing of pi, it's always going to be the whole circle.
It's going to be
like a quarter of the chart, then it's going to be half of it.
Yes. Yes. This is just, the chart is just me showing you why it's still the whole circle, even though it's only pi that we're covering, okay? All right, so again, sine of 11 pi over 6 would be -1/2, so this would be -2. Start again at -2, you're just traveling all the way around, you're somewhere over here. So again, that's gonna give you that whole circle, okay? Okay, no? Okay. Anything else from the homework you want to see?
Do number 1.
Sure. Okay, so what does it mean r equals 5? Okay, so you're good with like, okay, that's a circle centered at the pole. We'll call that a radius of 5. I only want it graphed between 3 pi over 2 and 2 pi. So this section right here would be your answer.
Okay, that's what I got.
That one's way simpler when it's centered at the pole. Yeah. Yep, you're good. And guys, the answers are posted on Schoology. You can look there if you want to check before you come in. But I'm always happy to go over any you have questions on. Were we fine with 4, 5, and 6, the 3 lines? Those were the easier ones, I think. Okay. Anything else before we start notes? All right, then. Find 8-3 in your notes packet. Stuff. All right, guys, we are graphing limacons today. These are things that you've never graphed before. We have inner loops, cardioids, dimpled, and convex. So you get 4 different kinds of graphs today. It's not bad if you pay attention to the little details. If you don't pay attention, it's hard, okay? So let's look at the first one here. We've got r equals 1 plus 3 sine theta. First, do you guys see how this is different than just a circle equation? Or a line equation or any of those? We've got the 1 plus something with our sine theta. Okay, that's the format that limacons always take. To graph this initially, we're going to go ahead and plot some points just so you can see the general shape. So we're going to graph the whole thing from 0 to 2 pi. So I will start by plugging in a 0 for my theta. So what is the sine of 0? 0. So what is r going to equal here? 1. Okay, let's fill in our chart and then we'll plot all the points at once. For sine pi over 6, any of the over 6s are good to plug in, because what is the sine of pi over 6? 1/2. So what do I get for r then?
2.
Okay, what's 3 times 1/2? 3 over 2 plus 1. 5 over 2 or 2.5, right? Either way. All right. Then I'll go all the way to pi over 2. I'm going to skip over the root 2, the root 3. Like, those are not fun to plot. So let's go to pi over 2. What's the sine of pi over 2?
1.
Okay, so what will r end up equaling here? 4. Okay, again, I'm doing another over 6. Let's do 5 pi over 6. What's the sine of 5 pi over 6? 1/2. So what do I get for r? Okay, 5 over 2 or 2.5. Then we'll go ahead and do pi. That's an easy one. What do I get there?
A 1.
Okay, sine of it is 0, so I end up with an r of 1. Good. All right, 7 pi over 6. What's the sine of 7 pi over 6? Negative 1/2. Oh, goodness. So negative 1/2 times 3. You can do it, guys. Negative 3/2 plus 1.
1.
Negative 1/2, right? Oh, goodness. It's not the trig that's hard. It's the adding and subtracting fractions. All right, we'll do just a couple more. I know I only have one spot left, but I'm doing 2 more. So let's do 3 pi over 2. What's the sine of 3 pi over 2? Okay, so what do I get? Negative 2. Good. Last one, let's do 11 pi over 6. Squeeze it in there. What do I get with 11 pi over 6? Negative 1/2 again. Okay. All right, let's plot some points. So r value of 1, theta of 0. That is right there. Flush. All right, 2.5 or 5/2. So I count out 2.5 and then pi over 6. That's 30 degrees. Feel free to relabel those with radians if that makes you happier. Okay, then 4 pi over 2. There. Another 2.5, this time at 5 pi over 6. That's 150. Okay, 1 pi. All right, then we have some negatives. So negative 1/2. Remember, I'm starting on the left side, and then from that starting point, I travel around 7 pi over 6. So negative 1/2 comes around off. Right in the middle there. You guys see it? All right, negative 2, 3 pi over 2. Where is that? Yeah, Kabir says at the top. That's right. So negative 2 and then travel all the way around. So right there. And then your last one, negative 1/2 all the way around 11 pi over 6. Ends up right over here. And at this point, with those dots, you probably are thinking, what in the world? Clearly, that's not a graph, right? Somebody one year was like, so we're graphed like a spider in the middle of a spider web? Yeah, no. All right. This type is called an inner loop. Inner loop limacon. Okay. Let me show you what the graph looks like. It is definitely different. The pole is not graphed on here, but the inner loop does connect through the pole, so you can always kind of throw that little dot in there if you want. Makes it look even more like a face in the middle. All right. Watch me graph it, and then I'll give you plenty of time to graph it yourself. So this part is almost a circle. And then you go through the pole, back. This should be a little more curved on this side. There we go. It's almost circular shaped, but then you've got that little loop in the middle. I think you can see why it's called an inner loop. The name makes sense. You can see how these will be interesting when I say graph it from, you know, pi to 3 pi over 2, right? You're going to have to pick out that little piece. So you've got to be very comfortable with the whole shape first so that you can graph certain sections of it. You'll get there. Anybody questions? Yeah, it's like, you know, it's like spirograph when you were a kid. Like, that's what you're doing. You're very rotational with all of it. Okay, so we're going to go through and graph the 4 different types, and then we'll talk about how you can identify them just from the equation. Okay, so our second one, now we've got 2 plus 2 cosine theta. So we're just going to go through our values again. Theta of 0. What is the cosine of 0? So what do we get for r? Okay. Now, do I want to pick pi over 6 again on this one? Good. You guys are getting better. All right, cosine of pi over 3. Okay, so what do I get for r? Plus 1, 3. Because the half times 2, yeah, you see it, okay. All right, what about pi over 2? What's the cosine of pi over 2? 0. So what do I get for r? 2. Then I'll go to 2 pi over 3. What is the cosine of 2 pi over 3? Negative 1/2. So what do we get for r? You already said it, I think. 1. All right, if I go to pi, what's the cosine of pi?
1, negative 1.
The cosine of pi is negative 1, so what do I get? Yes. All right, I want to go 4 pi over 3 next. You guys see I'm just working my way around the circle, right? Okay. What is the cosine of 4 pi over 3? Negative 1/2, so what do I get? 1. Okay. 3 pi over 2, what's the cosine there? Okay, so what do I get? Okay, good job. Yeah, you see a lovely pattern here, don't you? Let's do one more. Let's do 5 pi over 3. Okay, cosine of 5 pi over 3. Is it positive or negative 1/2? Positive. Good. So what do I get? 3. I think you definitely see a pattern in your numbers. Okay. All right, we got to plot them. 4, 0. 1, 2, 3, 4. 3 pi over 3. So that's 3 and then 60 degrees. 2 pi over 2. 1, 2 pi over 3. 0 pi. 1, 4 pi over 3. 2, 3 pi over 2. 3, 5 pi over 3. All right, I'll give you a second, make sure you're caught up with this stuff. Okay, this one is called a cardioid. Cardioid. What shape comes to mind if I say cardioid?
Heart.
Heart. All right, let me draw it. You guys see the little bit of a heart shape in there? Use your imagination. I mean, it's a very roundy heart. Pac-Man instead, is that what we said? That is what a cardioid looks like. And now that was a cosine one, so it's like symmetric across the x-axis. If it was sine, what do you think would be happening? Yeah, you'd have a cardioid one way or the other, either up facing, down facing. We'll look at all those different things, but that's the general shape. All right, let's draw another one. All right, guys. I'll give you the thetas. I want you to try to fill in your chart for me this time. The same thetas as last one, since it's cosine again. Try to fill in your r's, and then we'll plot them together. You can look up here and check the chart when you're ready. It's a lovely pattern for you. There is no 0 this time, you are correct. So this one will not touch the pole. All right, so I'm going to start plotting. This one is called a dimpled limacon. They're all limacons, but we just say dimpled for this one. So inner loop limacon, cardioid limacon, and dimpled limacon. When I draw it, Luckily yours is prettier than mine on this bottom side. Let's see if I can fix that. Do you guys see how there's just a little dip on the one side? That's the dimple. It's not as extreme as the cardioid, and it doesn't go to the pole the way the cardioid does. Okay. All right, guys. Any questions there? We'll do the last one, and then I'll see if you're noticing any sort of patterns or what's happening, okay? Okay, another cosine one, so guys, your thetas will be the same. 0, pi over 3, pi over 2, 2 pi over 3, pi, 4 pi over 3, 3 pi over 2, and 5 pi over 3. This is your last limacon. So fill in that chart for me. I'll give you a second here. Are you seeing a pattern on this one too? Look when you're ready. And this one is called a convex. And yes, you are going to have to remember the names of these, because part of your test is going to be identify the shape. And so you've got to know what it's called if you're going to identify it, okay? Don't just say that one that had like a little dip in it, like that's not a name, okay? All right, so I'll plot these. So 6, 0 is actually off your graph. 5 pi over 3. Try to draw this one. It's almost just flat on that one side. What shape are we getting closer and closer to? Yes, circle. All right, do you notice any patterns if you look at like the first numbers, the 1 and 3, and then 2 and 2, like what's happening here? Yeah.
Does it increase the A numbers in front of it? that increases the shape.
Mm-hmm. And it's the ratio between these. So that ratio would be 1/3. This one would be 2/2 or 1. Here then we're at 3/2. You guys see that first number? The ratio between the two is getting larger. And then here we're at 4/2, all the way to 2. So that's kind of outlined for you on the paper here. It's really small, the equations here. It's r equals a plus or minus b, and then either sine of theta or cosine of theta, depending if it's on the x or y axis. And so you're just looking at that ratio. If that ratio is less than 1, like it was in our first graph, we had 1/3 there, that's an inner loop. If it's equal to 1, it's a cardioid. Between 1 and 2, that's the dimpled limacon. And then 2 or bigger is convex. We don't really look at limacons in terms of circles because we've already talked about how you recognize the circle. It didn't have an A value, and so that is why it was a circle. Is everybody okay with that ratio, like the pieces that you're looking at there? Okay. All right, so let's try to graph some over a given interval. And obviously with sine, cosine, pluses, minuses, like they look different on the graph. So these are going to take a lot more practice for you to get better at just identifying where it is and what it looks like, but we'll keep working on them. So number 1 here, we're going to graph it over this specific interval. So again, kind of like your homework with the circles, when it's a specific interval, you really do still have to plug in a few points. You should absolutely have in your head what the whole shape just looks like, a visual idea of it, but then you're going to plug in some points to get the actual interval we're looking for. So 1 minus 2 sine theta, without graphing anything, is that inner loop, cardioid, dimpled, or convex? Inner loop, okay, excellent. All right, so, and it's sine, so I would expect it to be symmetric to the y-axis. I've got that in my head. But I'm only going to plot from 0 to pi, so I'm going to think about those values. I'm going to make a little chart. All right, so when theta is 0, sine of 0 is 0, so what do I get? 1, yes. All right, what else do you want to pick in between 0 and pi? Good, pi over 6, because it's a sine. Plug in pi over 6, what do we get? Okay, so what do I end up with for an R value? 0, yes, okay. Then I'm probably going to go to pi over 2. So what's the sine of pi over 2? 1. So what do I get for my R? -1. Good. I'll do the next over 6, so 5 pi over 6. What is the sine of 5 pi over 6? 1/2. So what do I get? 0 again, yes. Makes sense, right? First and second quadrant for sine should give you the same thing. And then the last one we would do is pi. So what is the sine of pi? So what do I get? 1. Okay. We okay with the chart? Okay, let's plot them. 1, 0 is over here. 0 pi over 6, that's the pole. -1 pi over 2, that's down at the bottom here. 0, 5 pi over 6, that's a repeat of a dot we already have, right? And then 1 pi, so we're over here. Okay. you know your inner loop is going to have like that. That's a terrible drawing of it. That's what's happening with the inner loop, right? So even though we only have these 4 dots, you have to figure out what it is. Connect them in order. It will help you graph it. So, you know, first point was over here on the right, and then it went through the pole, and then it came down to the bottom, and then it went back to the pole, and then we ended up over here on the left. Okay? And that's your graph. That's the answer. That tiny little inner loop part in the middle. But connect them in order. Otherwise, it gets really hard. And that'll be true with this and everything else we graph for the rest of the unit. Circles, it wasn't that big of a deal because you could easily see which section of the circle you have, but it really helps with these. Questions on that one? Okay. It seems weird that an interval to 0 to pi, which gives you essentially half of your graph, that tiny little section is half of your graph. But it is. All right, let's look at number 2. Is that inner loop cardioid, dimpled, or convex? What do we think? Convex. Yes, the ratio you're looking at. 3/1. It doesn't matter the pluses and minuses. And then I go, okay, 3/1, that's bigger than 2. This is a convex limacon. It's a cosine, so it should be symmetric along the x-axis. I want you guys to try to graph this one. I'll help you out with your chart. You're going to want to do pi, 4 pi over 3, 3 pi over 2, 5 pi over 3, and 2 pi. I'll give you some time here. Try to graph it, talk to each other. I filled in the chart if you are struggling on that or need to check. Make sure you've got those right. Again, talk to your neighbor, see if you've got the same graph. Make sure you can tell which side is the convex side, like the flat-ish side. All right, guys, so there are your dots. Which side is the flat side, the right side or the left side? The right side, okay? Do you see how that point is much closer to the pole than the left side? The flat part is the part closer to the pole, okay? So this is your sort of flat part over here. But again, just connect them in order, flatten it out a little there. Hopefully yours looks prettier than mine. Okay. That's it. How'd we do on that one? Good? Okay. Yeah. You got it, Robert? Okay, good. All right, guys, turn the page for me. And stop me if you have questions. Okay. Let's go ahead. Cross out number 8 for me. We are not doing that graph or anything like that graph, so get rid of that guy. All right, for the little in-class practice here, I want you to do 3, 4, 5, 6, and 7. Try to graph these. We'll see how far you get. We'll check in here in a little bit. If you want to go through and name them all first, you can, and then start graphing. So I'll give you a few minutes here. Yeah, go ahead. Yes. And then I'll put the key up. We'll see how you did, okay? You guys, I have some old trig quizzes I'll pass back to you. This is an older one, so I probably should have passed him out the other Maybe some good fire pits and then these like, but it's still, I don't know if yeah. Making progress now, right? Do you think the inner loops are the hardest to do over a certain interval? I think you were gone. Must have been it, because you got one of them right, not the other one.
Yeah, I got the 6 on the board.
Yeah, so I think you were gone that day. Yeah. The first one.
Is that point you grabbed right in the loop?
That's like the end of the interview. If that makes sense. I'll put it up in a second. The inner loops are super hard to visualize, yeah. You'll get better at it, I promise. We'll do some matching things too, so you get like a better visual.
Yeah, exactly. That's what I'm saying. Yeah. So I mean, technically, I'm on this. No, the radius. So if the like if it's 3 over -2, then that's less than 1, right? So,
No, because it's the absolute value of the A and B. Yep. All right, guys, the first couple are up there for you if you want to check. I'll keep going. You what? You grabbed the first one, right? Nice work. How are we doing on 1 and 2, guys? Robert, what's going on? Trouble? Okay, good. So what's negative 1 Okay, 3 minus 7.
It's like negative.
Like that is a
Oh, yeah. Yeah. I don't.
Okay.
I just people know.
We're just excited.
I was excited.
Yeah. I'm taking the phone.
You know you should still put
No, as long as you can draw an accurate shape. You know what I mean? Like, that's hard
Are
part.
very bad.
And then make sure you do the wood thing.
Yeah.
Well, that one is. Yeah. Yeah, don't make it. That's circle kind of part.
So how do you want to mention one half plus 3 halves and
We're getting 3 heads.
like 3 plus half. Oh, I got to get 6 half. Oh, that's what I was
3 minus $3 minus 50 cents.
got to do that. Triple that.
I know.
So for the R, does this just mean you can't have an R like
It's just saying this window goes to -5
Oh,
and
so
5.
and, like
It doesn't.
you really have to pay attention
It's like
to
a
it.
whole lot of notation. That doesn't
Oh,
you
okay.
just really need the equation, and then you can graph it. And these
Okay.
are all 0 to 2. So
Okay, so like these things don't
you
matter.
don't really need
Okay.
a lot of extra stuff on that. I'll explain. I put the last 3 up here, guys, because we are running out of time. Homework is actually easier than lecturing. Show you something on your homework. So guys, the homework 8-3 looks long, like it's multiple pages, but it's just because there's like weird extra stuff on the pages. So if you look, this is your homework. This like little grid thing up here, you don't have to do anything with this. That's a whole other way to look at graphs, but we're not going to do it. You just need to graph down here. The equation is in there, and then the window, that's just the R part of it. That's just saying here's what you see, like here's what's showing up on the graph. Like this actually goes from -5 to 5 for R values. But all of your thetas, I believe, are 0 to 2 pi. So for all of them, you're just graphing the whole thing. Okay? Does that make sense? So it's 8 graphs. And it looks like a whole lot of pages just from the way it's mixed up. Okay? Alright. You can just cross these out if you want. All you have to do is graph down here, graph the whole thing here.